Please note that there is a small delay between our broadcast and what you will be receiving, and for that reason, please, you can type in your questions on our live chat at the moment, and I will see your questions on the live chat. And also I have my colleague Jacobus. If I don't see your questions or whatever it is that you want to bring out or point out during my webinar. So right now it's 13:56 and we will wait until 2 o'clock to proceed and start my webinar. Thank you. One minute before my webinar starts. Almost time for me to start with my webinar. Okay, everyone, it is exactly 2 o'clock on my watch. Like I said before, welcome to my webinar for today. And today I'll be modeling a warehouse in Prokon Frame. My name is Mamjakele Swale, and I am a Prokon technical consultant at Micrographics. So the agenda for today's webinar: firstly, I will introduce Frame to you guys. Then secondly, I will start creating my model. So with my model, I'll start creating the nodes. Then I'll move on to populating my sections and materials table. And then from there, I'll start building my structural model. And then from there, I'll move on to assigning loads to my structural elements. And then from there, I'll run a linear analysis. And then after that, we'll assess the outputs after running our analysis. So like I mentioned, let's start with the introduction. So introduction to Frame. So Frame is a structural modeler. So you can model structural buildings with Frame. It can either be 2D structures or 3D structures. So basically, Frame is the same as Sumo, but they have different modeling philosophies. And then models can obtain or have or contain different multiple material types in it. So basically you can have either concrete, timber, or aluminum, depending on the material that you want to use on your building. And then models can contain thousands of distinct sections. So you can have I sections, or you can have rectangular sections, you can have slabs, you can have different types of elements really. And then we have different multiple analysis type. So you can run either a linear analysis, a non-linear analysis, and also a backlinking analysis. So there are different types of analysis within Frame itself. Then moving right along, so the model that I'll be modeling today will include or will have columns, rafters, haunches, purlins, side rails, eave beams, and then it will have a storage platform inside of the building. Then my frame model, so I'll have a portal frame warehouse, which will be 23.15 by 55, and it will be 9 meters high. It will also have overhang rafters on this side, as you can see, and there will be 3.15 meters from the first column or on either side of the building. And then my rafters are at 10.147 degrees, and then my main storage platform will be 13.5, and it'll also be 55 meters wide, and then it will only be 4.295 meters high. So I am going to launch Frame so that we start with our modeling. So I'm going to start off by defining my nodes. So for the column, we'll start with node 1. So with node 1, because of the rafter overhang, we'll start at 3.15 meters, then Y and Z will be both 0. And then within node 1, for the column, so I want 7 extra nodes, and the node increment should be 1, and the spacing between the nodes in the Y direction should be 1.2 meters. Let me just change my viewpoint. Then let's have the elevation, the Z elevation. So this is what you would see. And then my next node will be my eave node, which will be just above the 8. So it will be node 9, also at 3.15 in the X direction, but it will be 9 meters high. And then 0. Then I'm going to start defining my top chord. So it'll be node 10, which is where the haunch will end, or the entire length for the haunch. So it'll be at 4.63 in the x direction, and then it'll be 9.26 meters high, and then 0 for the z dimension. And then I'll have node number 11 where I will start placing my purlins. So it'll start at 4.17, and it will be 9.25 high. And then for the z dimension, it will be 0. If you leave the z direction open, the program will automatically assume that it is 0. And then I want 5 extra purlins. Node increment should be 1, and then the spacing between the purlins is 1.561, and then they should be increase by 0.275 in the y direction. This is how this should be 4.71, sorry. Yes. So the gap between where the haunch ends and then where the purlin start is mainly significant. So the next point or node will be node 17, which will be in the middle of the portal frame. So the x direction will be 13.15, and then it'll be 10.76 high. And then I will start defining the second part of the top chord on the right hand side. So let's say node 25, it'll be the if note on the right hand side. So it'll be 23.15, and it'll be 9 meters high. And then also on the other side, node 24, 21.67, which is gonna be the same node as node 10, where the haunch will end on the right hand side. So it's gonna be 9.26, and then node 23, 21.59, then it's gonna be 9.28 in the y direction. And I want 5 more purlins, but this time it'll be -1 for the node increment, because I'm moving from 24 to 18 actually. Yeah, -1, and then -1.56 because I'm moving from right to left, and then 0.275. So there we have defined our top chord. So now the next thing to do is for us to define the column on the right hand side. So the last point at the bottom of the column is going to be node 33. So it'll be 23.15 on the x direction, and then it'll be 0, 0, because we're defining that bottom node over there. And then in between the column I want 7 extra nodes, because we are moving from node 33 to node 26. it will be -1 for node increment, and then I want them spaced 1.2 also in the y direction. So there we have it, our fully defined first portal. So now what I want to do is I want to copy this portal and have 11 extra bays on the Z direction. So what I do is I'm going to use the block copy function. So I'm going to say B, and I think it's line 1, so you can tell which line it is from the bottom over there. So it's line 1 until line 9. So I'm going to block copy line 1 to 9. Like I said, I want 11 extra bays, and then node increment will be 33, and also I said the spacing between the bays will be 5 meters. Press enter. If I change my view to default, then I have copied over the first portal to have 11 extra bays. So I'm gonna go back to my elevation, my Z elevation, close. So now I'm gonna enter or define my overhanging rafters on the right hand side, on the left hand side, and also on the right hand side. So before I use this, I need to check what is the last node number so that I may be able to proceed. So it's 396, so the next node will be 397. Let me switch back. Yes, and then on the X direction it will be 0, and then I want it to be 8.417 high. So there's the first node, and then the second one will be 398. It will be only 1.588 on the X direction, and then it will be 8.730 high. Then I'm gonna put in the last node on this side, so it's gonna be 2.2, and then 8.84 meters high. So there I have defined my overhanging rafter on the left hand side. So let's do the same thing on the right hand side. So the next node will be node 400. It will be at 24.1 on the X direction, and it'll also be the same height as node 399. So 8.84. Sorry. And then the second node 401, it will be 24.712 in the X direction, and then it will be 8.73 high. And then last node for the rafter overhang will be 402, and then 26.3 in the X direction, and it will be 8.417 high. So there we have. So now what I'm gonna do is I am gonna define my storage platform. So I'm gonna start with the beam. So the first point for the beam will be 403, and I'm gonna start it from the right hand side, so it will be 23.15, and then like I said, it's 4.295 high, and then I want 6 extra nodes between the beam. Node increment will be a 1, and then in the X direction X increment will be 13.15, and then 4.295. You can see how the nodes are defined. But if I use and under this table for use and Y or increment no, if I say yes to specify that the increment should be between nodes, then this is how my beam will be defined. And then the next node for the column of the storage over there, it's gonna be 410, and then it will be in the middle of my portal, so it's 13.15, and then I want it just below point node 409, so it will be just 4 meters below it. And then I want 4 extra nodes between the column. Space node increment should be 1, and then 13.15 for the X increment. And just like how we did for the beam, we will say yes to specify that the increment is between the nodes. So let me change my view back to default so that I can see everything. So what I want to do is block copy from this node over there, which is line 11 up until node 410, so that's line 18. So I say block copy line 11 to line 18, and I want to copy them over to the other 11 base, so 11, and node increment 33, and then in my Z direction it will be 5 meters. And there we have our model. This looks so good. Anyway, let us save our project. Let's just save. Let's just say webinar, save. So before we define our, or before we do beam element definition, let's firstly define our beam sections. So first I'll have column, but I'll name it as COL, then rafter, purlin, that's fine. And then I said we'll have side rails, so side RL, and then I'll have if beam BM, and then I'll have haunch, and then I'll have overhang, so I'll say OHR, which is overhang rafter, and then overhang haunch, and then I'll have brace, and then I'll have storage platform beam, and then storage platform column, and then storage platform back beam, so it'll be that beam on this side of these columns. And then I'll have storage platform front beam, so it'll be the beam on this side of the storage platform. So for the column, I'll have an I section, sorry, so it'll be 533 by 210 by 82, as well as for the rafter an I section, similar section. And then for the purlins, I'll have the lip channel, the 125 by 75 by 20 by 2, and then the side rails, same lip channel, but I'll have a 150 by 50 by 20 by 2, and then the eaves beam can be the same size as the side rail, 150 by 50 by 20 by 2, and then the haunch. So before you select the section for the haunch, you have to click haunch and then specify the haunch depth, which is 0.25, and then it must be the same section as your rafter. So it'll be a 533 by 210 by 82. So I'm gonna click on that, and then for the overhang rafters, I will choose an H section at 254 by 146 by 31, and then also haunched 0.2, same section as the above rafter. And then for my brace, I'll have an equal leg, a 70 by 70 by 6, and then for my storage platform beam, I use 533 by 210 by 101, and then the column, I'll use the 254 by 146 by 37, as well as the back beam. And then the front beam, I'll choose a smaller section. Then I go to my beams so that I can start defining my beams. So under beams, let's start with the column over there, 1 to 2 double hyphen 9, the name column, and then from 9 to 10 it's gonna be haunch, comma rafter, and then from 10 to 11 double hyphen 16, it'll be my rafter. And the minute I start defining, you will see the color change in the display window. And then 18, that beam over there, 18 to 19 to double hyphen to 24, that's also rafter. You can necessarily leave it open, because the program will automatically assume that the section at the top is the same as the one at the bottom, but you can just select the section, that's fine. And then from 16 to 17, also rafter, comma haunch, and then 18 to 17, rafter, comma haunch. Then the column on the other side, then 25 to 26, then double hyphen 21, and then to 403 to 30 to 31, then double hyphen 33, and that's a column. Yes, there is one little section that I forgot, so it is 24 to 25. Also rafter, comma, haunch. That's it. Let me just change my view so that we can close. Let me switch on my 3D. So there we have. Right, go back to my default view. We can switch on the 3D just to see. So now I want to copy these sections to all of the other bays. So it's gonna be the block copy function again from block 1 to 8, and it's gonna be 11 number of extra 11 bays, then node increment 33, and there we have. So we are going to start defining our purlins. Let me switch off the 3D. So 9 actually let's set it's from 11 to 44, then double hyphen 374. Let me just check. Yes, and then that's my purlin, and then I am going to insert the angle of rotation about the element's z-axis. So I'm gonna make it 10. So I'm gonna have it torsionally fixed in one end. So this is restraint against rotation about the element's longitudinal axis. So also on the other end, torsionally fixed, and then 5 extra 1. So this is what we'll have, and then 18 double hyphen 2 381 purlin. So that's the purlin there, over there. Also it'll be minus 10, the rotational angle, because it's on the other side. T also 5, node increment is 1. So there I have my purlins, and then I'm gonna define my side rails. Just rotate on this side, so it's 2 to 35, then double hyphen 365 side rail, and then also I'm gonna rotate 1, also torsionally pinned. I need 6 extra. Yes, I think 1, 2, 3, 4, 5, 6. Yes, 6 extra. Node increment is 1. Then I'm gonna define the ones on this side. So it's 26 to 59, 389. Also side rails. 90 directionally pinned on one end, and the other end as well, 6 as well to 1. There we have our side rails. Then I'm gonna define my eaves beam. So I'm gonna start with that one. So it's 25 to 58, then double hyphen, the last point is 388. So eaves beam So I can use the copy function to copy it on this side. So it's 1 minus 16 because it's 25 minus 9. So then I'll define my rafters for the overhanging. So it's 397 to 398 to 399. So it's gonna be OHR, and then from 399, actually let's start with 9 to 399 rather. So it's gonna be OHH comma OHR, and then from the other side, the right hand side, 25 to 400, OHH comma OHR, so, and then 400 thereafter. So it's going to be 400 to 401 to 402, also OHR. And then I'm gonna start defining for the storage platform. So it's gonna start from there. So it's 40, 403, sorry, to 404, and then to 40 double hyphen to 409. I think, yes, sorry. And that is our storage bin. And then 409 to 410 for the column, double hyphen 414. And then 403 to 437, 403 to 437, and then that's the storage back beam. And then for the front beam, it's going to be 409 and then 42442. Then I'm gonna start copying over to the next page. So 1133, also 1133, 1133, 11. The minute I start putting in the number of extra and note increment, you will see everything starts falling in. And then 1133, also 11. There we go. Then lastly, we're gonna do the purlins on these sides. So I'm gonna have 760, which is that point over there to there, to 727. And then that's purlin. It's gonna be 10 minus 33 to copy it over, and then 764 to 731. For these, I'm gonna add rotation, and then I'm gonna pin them. Let me start with the one next to it. So it's 7612, 728. That's a purling. 10, pinned, pinned, 10, and then on the right hand side, 765 to 732, which has a purling 2, but minus 10 for the rotation, also pinned, pinned, 10, minus 33, and then the last one will be 764 to 731, also purling, minus 10, pinned, pinned, 10 to minus 33. Let's see, that's it. Then we are going to add bracing from note 9 to 47, 9 to 47, brace. We'll make them pinned, also pinned, and then I'm gonna make 2 copies. Note increment 165. So it's to 9, then I'm gonna add my bracing, 9 to 47, then the brace, which is this one that you're seeing already, and then I'm gonna add another one from node 14 to 42. Also it's a brace, also pinned, pinned, 2 more copies, note increment. So if you check on this, you'll see it copied the brace on the middle of the bracing on the middle bay, and also on the last bay. And then also from node 47, which is this one, to node 17, I'm gonna add another bracing, 47 to 17, and then brace, also pinned, pinned, 2 to add, yeah, in the middle bay and also on the last bay. And then I'm gonna have from 50 to 14, still brace, pinned, pinned, 2, and then 165, note increment. And then I'm gonna add on this side the bracing from node 25 to 53, 25 to 53, also brace, pinned, pinned, also 2 to 165, so that we copy it in the middle bay and also on the last bay. And then from node 58, which is that node there, to 20, still brace, pinned, pinned, 2, then 165. I want 2 extra meaning it must copy it on the middle bay and also on the last bay. And then from node 20 to 50, I'm gonna add another bracing. Brace, pinned, also pinned, 2, and then 165. And then lastly, from node 53 to 17, brace, also pinned, 2 to 165, and then that's our bracing. So there we are, our fully defined structure. Let's just save, and then from there we're going to shells. I'm gonna define my first shell, so I'm gonna have it at node, starting from node 409, so 409 to 403, and then the next node will be 436, and then the last node will be 442, which is that node over there. And I need 10 extra, spacing will be 33. So there you have. And then the thickness of my shell will be 0.001, and I'm gonna make it a steel material and also rigid to allow so that the shell shouldn't be flexible at all. And then I am going to choose a shape of functionally graded material, and then I'm going to move to my supports. So support 1, I'm going to select Y, which is the Y, X, Y, and Z, and then I'm going to copy it over to the next space, so 11, then 33. Then we also add support at node 33, also a translational support, also 11, and then node increment 33. There you have it. Then if I rotate the first node for the storage platform, it's, so we're going to 414, 11 extra base 33. And then if we rotate this, we will notice that the supports have been added to all of the columns on the storage platform as well. You can also define there or leave it open. And then we move to beam loads. I'm going to start with dead load. We are only going to apply it on certain purlins, not all purlins. So I'm going to start on the eaves beam over there, so 9 to 42. Direction will be Y. And then W low will be minus 0.62. And then node 11 to 44. Let me just write all my nodes, my beams that I'm going to apply the loads on, which will be some of the purlins and the eave. Then to 15. And then 402 to 435. And then 401 to 434. And then 398 to 431. And then 397 to 430. So mainly it's the edge beams. So let me just apply the load. So in the Y direction, which is vertically applied onto the beam, and then for this one it's going to be minus 1.25. And then I'm gonna add a live load, also apply a live load also on the same beams. So I'm just gonna copy over these beams, also on the Y direction. And then for this first one, it's going to be minus 0.939, sorry, and then minus 0.78, minus 0.78, minus 0.78, minus 0.78, minus 0.78, also minus 0.78, and then lastly I'm going to apply a wind load at 0 degrees. So from node 9 to 42, 11 to 44, and then 18 to 51, 20 to 35, 2 to 35, sorry, and then 402 to 435, and then 401 to 434, and then 397 to 430, and then 398 to 431, and then in the local direction parallel to the beam local axis, so it's L, 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 and then we go apply our loads. So for this point it's gonna be 0.44, 0.88, and then 0.21, 0.67, 0.21, 0.21, 0.21, and then 0.21. We can also apply W at 90 degrees. Still with the same notes, you can copy over here. Still also on the local direction, L, 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 and then first node will be 0.26, 0.52, 0.52, 0.52, and then minus 0.15, minus 0.15, 0.52, 0.52, and then let's block copy from, so that we can apply the loads throughout the purlins that we have selected to apply loads on. So it's from B1, yes, until B30. So it's 1 to 30. Number of extra is gonna be 10. Then note increment 33. So let's quickly apply. Time is not on my side. A live load on the shell. So it'll be, if you switch on the shell numbers, 11 shells. So it will be from shell 1 to 11. Y direction. Oh, sorry. I have to make sure I am on the edge load. Sorry. So it's live load. So from shell 1 to 11, Y direction -10. And then we move to load combination. So locate C1 will be DL, DL, and then 1.5 for ultimate limit state, and then for serviceability limit state will be 1.0, and I'll have C2, DL, L, 1.2, 1.6, C3, DL, WL0, 0.9, 1.6, 1.0, 1.0, and then C4, DL, WL90, 0.9, sorry, 0.9, and then 1.6, 1.0, 1.0. Let's go file save. Let's go to settings and then full 3D. But before that, let's go to general and then click add own weight, settings, linear analysis, MKL. Let's start. And yes, we managed to analyze with no errors and everything. So at the moment you're seeing, or it's displaying our maximum deflection. So if we go to output, it'll give us the deflection. If I change my magnitude to 30, you will see the deflect to 100, you will see the deflected shape. So maximum deflection on X will be minus 4.17, and then Y for minus 14.74, and then you can also see the different reactions on the different columns that we have, and then you will check beam forces, but for actual it wouldn't be too much. So let's switch to moments, X moments, and then Y shear, and then we'll have Y moment, and then you can check your beam forces. If you click, you can specify the beam. Let's say for instance I say from beam 381 to 382, and then double hyphen 388. Let's see what it does, and then we can select all, click OK, and then it will show us for that particular beam the axial forces, the X moment, the Y shear, the torsion, and then the Y moment, the X shear. And then if we click on the plane stresses, it will show us the plane stresses for the shell that we also modeled into our model. And then moment and forces. And then we have the outlook, where you can also add this to or send it to our calc sheet. And then we can go to our calc sheet. This is how our calc sheet look, and then we can switch to design links. So under the design links, you can design different things, from your pad footing to your concrete column, and then you can design also, you can do strap design or combine design. You can also do connection design for the apex, and then the column and beam connection. I see I only have 3 minutes left for my webinar. Any questions before I proceed? Any questions before the webinar ends at 3 p.m.? Just quickly do one connection. Let's see with the apex quickly. Once it opens, this is exactly what you would see, and then you can go ahead and do your design. So that's about it for my webinar today. Any question, guys, before we close off? 2 minutes left. One more minute left. I see Yakova's excited for this. I was also excited for it. Thank you for joining, Yakovas, as always. Any more questions? All right, it's almost 3 o'clock, guys. Thank you for joining my webinar. I hope you enjoyed it and learned a few things from it. If there are any questions, please send through our email. Also, you can check out our YouTube page for more videos from my colleagues and myself. But thank you for today's training, for today.